magnificently magical Monday
Sorry for interrupting your beauty sleep, but, are you Mr. Red?
Yeah?
Do you know about the unit circle?
No?
I'm so sorry about this.
A unit circle is a divine tool that helps people understand trigonomic functions and angle measurements. A tool that has truly transcended time and space, mesmerizing us mortals with its glory. What might seem intimidating at first to some quickly becomes easy when you realize the importance of sine, cosine, and tangent, or for short, SOHCAHTOA. This represents the basic trigonometric functions that can be used for a right-angled triangle. To tell the different sides of a triangle, we have to know the acute angle of theta, which is the reference point that will help us find the ratios that define SOHCAHTOA. Isn't that just swell, Mr. Red?
Morning, Mr. Red. Did you get some good sleep?
I have many questions right now, such as, who are you, where am I, and why did you kidnap me?
Simple! I'm Ace the Eagle, and you're on a plane over the Pacific, and your life is about to be changed forever.
That didn't answer my question at all.
Look! Howard Hughes!
Wait, what? The Greek letter of theta is used in math as a variable to represent measured angles, such as sine, cosine, and tangent. Now, it's important to remember how to read sine, cosine, and tangent on a unit circle. The four quadrants of the unit circle come together to make 360, and you start reading it from the right side of the x-axis and move counterclockwise from there. It is fact that any x value on the circle will represent cosine, and any y value will represent sine. To find tan, we must divide sine over cosine. Let's put this into practice. Little Billy was walking with his mom one day, and was wondering what the sine and cosine value of 60 was, as any normal kid would. So, like all loving parents should, she pulled out her unit circle to find that the cosine of 60 is 1/2, and that the sine value is the square root of 3 over 2. It was then that the curious little Billy chose the path of chaos, and asked his mom what the tan value of 60 was. So his mom proceeded through the dark alleys of tangent, and divided 1/2 by the square root of 3 over 2. So, through the process of division, she found that the tangent of 60 was the square root of 3, all of which was to the content of stupid little Billy.
Psst. Hey you, over here. You know about the unit circle?
Through contrived and twisted measures, I do now.
Then, do you know about cosecant, secant, and cotangent?
No.
Oh, brother.
Cosecant, secant, and cotangent are the inverses of sine, cosine, and tangent, respectively. For not only is the fraction flipped for a right triangle, but the sine, cosine, and tangent values are flipped on the unit circle. For example, the cosine value for 300 is 1/2, but the secant value for 300 is 2. Meanwhile, the sine value for 300 is the negative square root of 3 over 2, and the cosecant value is negative 2 times the square root of 3 over 3. Now for the hardest part, the cotangent value of any part of the unit circle would be to instead divide cosine over sine. So through division, we will find that the cotangent value of 300 is the negative square root of 3 over 3. Let me guess, you're someone else a part of this cruel prank where you're trying to get me to learn about this dumb unit circle.
I mean, I was just gonna say that your shoes are untied, but I could do what you just said if you want.
The last few things you'll learn about while you're unconscious, Mr. Red, is coterminal angles and how to find the missing angle/side to a right triangle. Coterminal angles are the easiest things to understand with a unit circle. You can basically add and subtract 360 or its multiples in order to find an angle that shares the same terminal side. For example, a coterminal of 15 could be 375, for 15 plus 360 equals 375. Now to find the missing side of an angle, we have to first look at what type of function we are given for the equation. In this problem, we are given the values for the hypotenuse and opposite sides, so we'll make sure to use sine for our equation. To set up the equation, we first have to put the function of sine times 50, the known angle of the equation. Then, we'll put the sine fraction after the angle, for we'll then cancel out the missing side by multiplying each side by 10. And once the same equation is set up in a calculator, we'll then get the answer of 0 and 766 thousandths. When finding the missing angle of a triangle, we use the same process by finding what values we are given for the sides of a triangle. We can see in this example that we are given the sides of hypotenuse and adjacent, so we will use cosine in our equation. Our equation will be pretty straightforward, for we are using the inverse cosine to then plug in with our trigonomic fraction into the calculator. In this equation, we can also simplify 27 over 30 to 9 over 10. So with our calculator, we'll find that our answer is 0 and 451 thousandths. And so ends your long journey about the unit circle. I hope you're now a changed man after this lesson, and you think about the unit circle for the rest of your days. Don't let anyone else make you think otherwise, Mr. Red. Well, that sucked.